Good evening, everyone. Sir, in the last videos, we have covered some programs. Today also, I'm going to take some few programs. Okay, today I'm going to take only less time. So I'm going to remove these two programs like prime factorization and the power x to n, because these two programs I will cover as a part of recursion. In the recursion related programming, I'm going to cover those two, sir. That's why here if I explain, you people are going to get confused. That's why I'm not going to cover that. And 27th program, okay, is it correct? 26, 27, 28, 29. No, I think so. So 24, 25, so 26, 27, 28. Sir, the next program, what we have here is perfect number. Perfect number. Sir, when we can say a number is perfect number? Okay. Anyone having idea about this perfect number? Do you have any idea about this perfect number? If you have, can you please, which number is said to be perfect number?
7 to 9.
729. Any other? Yes, first of all, what is meant by perfect number? Right.
The individual digits of the number multiplication.
No. Sir, perfect number means if you take any number n, so sum of its factors excluding that number should be equal to n, sir. Example, if you take a 6, what are the factors of this 6? 1, 2 and 3 and then 6, excluding that number, that means 1 plus 2 plus 3. Sir, is it equal to 6 or not? Yes, then we can say 6 is nothing but perfect number. Okay, so in our programming terminology, if I am taking any other number, for example 10, so 1 is one of the factor, 2 is the factor, 5 is the factor and 10 is the factor. Excluding that number, try to add. Sir, 1 plus 2 3, 3 plus 5 8. Is it equal to the original number? No. So it has to return false. So like this we have. Okay, a perfect number is a number once if you calculate so individual factors excluding that number, if you perform sum of all these factors, it should be equal to the original number. Then such type of numbers is called as perfect numbers. Since we are depending on factors, right? I think we are not required to we don't have any multiple options for this. We have to write a simple code for this. Let us see how you can implement. Sir, something it is related to the previous program only, right?
Yes, sir. Except in the class value, we can sum that.
Yeah. Okay. So we are going to get divisions. Sir, here itself, I'm going to write some logic. Okay, here itself, I'm going to write some logic. What is that logic? I think here itself we can define one more function. Def is a perfect. It will take a number. So first we are going to calculate the divisions. So for that already it is going to return a list. So we have divisions function is there. Just if you pass a number, it will return that list. Sir, I need all the list items. Let us take L1. I'm constructing another list. From L1, from the first list. From which position to which position? From first location to last. For example, if you give input as a 6, these are nothing but the divisions, right? These are nothing but the divisions. Otherwise, here itself we can reduce this n, right? That is sufficient. I think this function is also not required. L1 is nothing but the divisions it is going to return.
Or we can take one column to left of the list of -1.
Yes, we can take like that also. So now I'm taking this here itself. I have reduced that last factor includes. Okay. So now I got all the divisions and I want to return if n is double equal to sum of n. That's all right. Whatever divisions that we are getting, excluding that number, if you add all these divisions, it should be equal to the original number n. If it is the case, is a perfect function is going to return true, right? So here I'm going to write under it is perfect. It is a perfect number. So it will return either true or false. If it is a perfect, it will return true. Otherwise, it is going to return false. Let us cross check how it is going to work. Py space I'm giving test.py. If input is a 6, yes, it is the perfect number. 7, it is not a perfect number. 8, it is not a perfect number. 12, it is not a perfect number. Okay, sir, 496 is the perfect number. Yes. Okay, and sir, 28 is also perfect. I think so. Okay, these are nothing but sum of perfect numbers examples. I think you people got a very clear clarity how you can able to check a number is a perfect number or not, and how to write this small code snippet for this application. Please confirm, clear up to this.
Sir, I want to find out the perfect number in between 1 to 1000.
Then you can write a loop, right? You can write a loop. So if you want to code for that, just here you can see. Here I'm going to write for I in the range of 1 to 1000. So what we have to do, if E is a perfect of I, then we have to print I. That's all. It will return the perfect numbers list. We have only these 3 numbers. Okay.
Yes, sir. Thank you.
So I request everyone to please confirm. Is it clear up to this?
Yes, sir. Yes, sir.
Yes, sir.
So in this function, you have called two functions. You are importing that function.
Can you please speak louder?
In this program, you have taken divisor function also, right?
Yes.
So are you importing that?
No, I'm not importing. I'm using automatically. I'm writing the code for that.
No, it is the first function is over there, and after that you are calling that. If that
You are asking from one function, can we call another function or not? Is it your question?
No. I got this, and I understand that if this function would be in another file, then we have to import, right? This function.
Yeah, if it is in other module, we have to import. Right.
Can we combine this in one function only? Or we
Sir.
have to keep it- Can we combine this?
Yeah, we can do that. We can do that. But
Yeah,
it is never recommended, sir. But it is never recommended because in the beginning itself I told. So whenever we are trying to solve the problems, maximum try to reduce the risk. You have to give the task to some other person, sir. Then only your efficiency is going to be improved. You have to manage all the activities. So I am calling is perfect function. Is perfect function job is what? You have to check whether it is perfect number or not. For that he need divisions. So again, he is not going to calculate the divisions. He is calling some other function which will return a list of divisions for the given number. So that function, whatever value returned, based on this I am going to invoke here. Like that it will be there.
For the becoming of code readability.
Yes.
Thank you.
Right. Sir, next program. Sir, I think we covered Pally and Run program. Have we covered Pally and Run? Yeah, we covered. Sir, now the next one, what we are going to take here is Armstrong number, sir. Armstrong number. Can you please tell me what is Armstrong number? Anyone having idea? Armstrong number. Anyone having idea? Ayo.
So Armstrong number is a number. The digits of number, cube of digits of the number is equal to that number, right?
Yes, good, sir. If you are taking any number, you need to take the cube of individual digits. Like first digit is 1 cube plus 2 cube plus 3 cube. Like if you calculate the sum of these cubes, 1 cube is nothing but 1, 2 cube is nothing but 8, 3 cube is nothing but 27. What is the result? 36. Is it equal to the original number? No. Then it is not Armstrong. If you take 153, so 1 cube, okay, plus 5 cube plus 3 cube. So 1 cube is 1, 5 cube is 125, 3 cube is 27. If you add this, we are going to get 153. Yes, it is the prime number. Sorry, it is the Armstrong number. Like that we have. Sir, it is something like
So you mean to say that every time we need to take the cube of that single digit?
yes,
Only cube, right?
yes, only cube. So what I'm going to do here, I will write a program for that. Just I will define. So a function called Armstrong number. I'm going to take a number n and I will check. First we have to calculate a sum, right? Initially sum is equal to 0 until the value of n is not equal to 0. But we need to store the value of n in temporary variable because at last n value will become 0, right? With whom you have to compare. That's why something like Pally and Run program. Okay. So now I'm calculating the digits. Sum is equal to sum plus d double star 3, sir. Okay. Double star. Yesterday class only we have discussed. Double star operator is used to calculate the power. Okay. Next n is equal to n double slash. That's all. Finally written if n is equal to t. So such a type of numbers, whatever we have, it is going to return. Let us cross check. Sir, nothing. Any mistake that we have done? We have to compare with the sum, not with that number, right? Sir, you can able to see 1 is Armstrong number because 1 cube is equal to 1. So 153 is Armstrong because 1 cube plus. Sir, I request everyone to please be on mute. Whenever you have a doubt, then only you can unmute. 153 just now we covered. 370 is also Armstrong number. 3 cube plus 7 cube plus 0 cube is equal to 371. Okay. Similarly 371. Similarly 407. All these are nothing but what, sir? Armstrong numbers. Like this we have. Okay. I think this small code snippet how to generate Armstrong numbers. It is very clear for you people. I think so. Any doubts, friends, up to this?
No, sir. Yeah.
So I think that is not going to be fixed cube. It depends on the total number of digits in a given number.
Yes, sir.
That number of
But yeah. But as of now, we are not going in detail, sir. Just try to understand how we are implementing the logic. That is our main concept. Okay. Yeah, I know it is depending on the number of digits. If it is a 4-digit number, so we have to take power to the power 4, right? So the next program, sir, I request everyone to please confirm. Clear up to this?
In that we can put the condition if a number digit is greater than 4, then it will
Yeah. Again, it will be somewhat big logic we have to write, sir, because you need to count the number of digits and then that power we have to take. Like it is again another task. That's why just understand how we are implementing these algorithms. Okay. Right. So the next one, what we have here is the next program, program number 28. Sir, strong number. Can you please tell me? Anyone having idea about strong number?
No, sir.
Right. Sir, if you are taking any number like 123, you need to calculate 1 factorial plus 2 factorial plus 3 factorial. What is a 1 factorial? 1. What is a 2 factorial? 2. What is a 3 factorial? 6. What is the sum, sir? 9. Is it equal to the original number? No. Then it is not a strong number. Sir, 145 is the strong number. 1 factorial plus 4 factorial plus 5 factorial. What is a 1 factorial? 1. 4 factorial 24. 5 factorial 120. If you add, you are going to get 145. So it is nothing but a strong number. Sir, I'm going to write code for that. Sir, just I'm going to take a strong. Okay. Sum is equal to sum plus. Can I take math dot factorial of that digit? That's all. And here compulsory you have to import which module, math module we have to import. Then I'm going to check whether it is a strong number. I'm listing out the strong numbers from 0 to 10,000. Sorry, 1,000. Let me give 10,000. Sir, you are going to get like this. Have you observed? These are nothing but strong numbers what we have. Okay. So I think that this application is also very clear for you. Right? Any doubt about this strong number, Armstrong number, Pally and Run, reverse of the number? Is it clear up to this, friends?
Suppose in this if we are not importing math, so to solve this problem, just
Yeah, we have to write again factorial code manually by ourselves. But already we know, right, how to calculate the factorial of the given number. We have several logics we implemented, right? So we can apply any one of that. Okay. Yes. I am requesting everyone to please confirm. Clear up to this, whatever I covered.
Yes, sir.
Right. So yeah, correct. Shantanu. So the next program, okay, what we have here is 29th program, which is nothing but Fibonacci sequence. I think everyone know about this sequence. Sir, we have multiple approaches are there for this, but I'm going for standard approach. In the recursion, I will cover. Sir, first two numbers in this sequence is 0 and 1. The first two numbers in this sequence is 0 and 1. Next number we can calculate by adding previous two numbers. What is the previous two numbers? 0 and 1, right? By adding 0 and 1, we are getting 1. Next number can be calculated by adding previous two numbers. 1 plus 1, it will become 2. Sir, next number we will get by adding previous two numbers. Sir, 2 plus 1 become 3. Next number we will get by adding 2 plus 3, 5. Next number we will get by adding 5 plus 3, 8. So next number by adding previous two digits. Like it will be repeated. Like it will be repeated. What is mean by Fibonacci sequence? Sir, by adding sum of previous two numbers, we are going to get a new number. So that sequence is called as Fibonacci sequence. That sequence is called as what? Fibonacci sequence. Okay. Now I have to implement a program for this. Let us see how you can write. Okay. Sir, here I am going to define FIB. FIB. So you can give any number. Up to this number, I want to generate Fibonacci. For example, consider FIB of I am giving 5. I need to get a list. So that's why I'm going to take an empty list. Okay. And at last, I'm going to return that list. Sir, I'm going to take the first number as a 0, second number as a 1. Okay. So I will append these two numbers into the list first. Then I'm going to write a loop for I in the range of, okay, for I in the range of n. If you take I in the range of n, how many times it is going to execute? Suppose if n is equal to 5, 5 times. If n is equal to 10, 10 times. But already two numbers I got right. That's why I'm taking n minus 2. Now C is equal to, try to add previous two numbers A plus B. Then try to append this C value in this list. Then A is equal to B, B is equal to C. That's all, sir. I will explain how it is going to work. For example, consider I am giving n is equal to 5. So what is the initial value of A, sir? It is 0. What is the initial value of B? It is 0. Sorry, it is 1. Now we are appending this 0 and 1 into the list. Right. Next, for I in the range of, so within bracket n minus 2. N value is 5. 5 minus 2 means 3. 3 times this loop is going to run. 0th time, first time, second time. In 0th time, what we are doing? L dot append of C. What is the C value? A plus B. What is the C value? A plus B. What is the A value? 0 plus B value 1. So your C will become 1. We are appending that C here. Then A will become B. What is the A value? It is nothing but B. What is the B value? It will become C. Since second time loop is running, C is equal to A plus B. 1 plus 1, 2. Try to append that into this. Then A is equal to B, B is equal to C. Loop is going to run one more time. Your C value will become 2 plus 1, that is 3. Append that 3. Then it will be assigned with 2, it will be assigned with 3. Sir, is there any loop continuation? No. Then it will close and we are going to get this. Is it a Fibonacci sequence or not? Yes. Let me check really for this. I am expecting output as 0, 1, 1, 2, 3. Let me check really whether we are getting that output or not. Have you observed? 0, 1, 1, 2, 3. Perfectly. The code is executing. I think, friends, you people got clear clarity how this Fibonacci sequence is going to work. Clear, friends?
Yes, sir. Can you explain the working of for loop one more time?
You need for loop one more time.
Yes, sir. Yes, sir. Yes. Working.
Oh, okay, no problem. So tell me your number, any number. For example, if I will consider n is equal to 6, okay? So initially, so this for loop, how it is going to work? I is equal to range of, okay, range of 6 minus 1, 6 minus 1, 6 minus 2, that is 4. This range of 4 is going to drop the numbers from 0 to 4 minus 1. How many times these instructions are going to execute? 1, 2, 3, 4 times it is going to execute. That is the concept. So why we are running 4 times? Because these first two numbers already appended into the list. That means we got first two numbers. Rest of the numbers only we require. That's why minus 2 I am taking. Clear, sir?
Yes, sir. Yes, sir.
Right. Sir, in the same way, sir, there is one more program is there. That program is nothing but Fibonacci sequence. Fibonacci sequence means what? First three numbers. Sir, 0, 1, 2. Next number is calculated by adding previous three numbers. 0 plus 1, 1, 1 plus 2, 3. How to get next number? Previous three numbers. 3 plus 2, 5, 5 plus 1, 6. Next one, 5 plus 6, 11. Next number, 9, 10, 20. Sir, next number, 37.
37.
Like this, we are going to get. Sir, same program only. So, FIB of, let us consider, I am giving 6. I will get 6 numbers. Let me drop here those numbers. First three numbers, 0, 1, 2. Next number is, just now we calculated 3. Next number is 6. So, next number is 9, 10, 11. Correct, right? 6 numbers. Sir, in the place of FIB, I am giving triple. Here also I am giving triple. Sir, in addition to this, you need to take one more number. You have to append C also. Sir, here n minus 3 times. Don't take C, try to take D. A plus B plus C. Try to append that. A is equal to B, B is equal to C, C is equal to D. That's all right. No other calculation is required. Sir, we are getting 0, 1, 2, 3, 6, 9. Yes. Let us die on this. Sir, I am giving n value is equal to 6. So what is the initial value of A, sir? 0. What is the initial value of B, sir? 1. What is the initial value of C, sir? 2. What is the initial value of D? As of now, it is not there. Okay. Sir, what is the list? In the list, initial 3 values will be appended. That is 0, 1, 2. Now, what will Shantanu? It is a Fibonacci sequence. Fibonacci means what? Previous 2 numbers we have to add to get the next number. Fibonacci means what? We have 3 numbers are there. By adding these 3 numbers, we will get next number. By adding these 3 numbers, we will get next number. By adding these 3 numbers, we will get next number. That is the concept. Okay. Right. Sir, now, sir, for loop, for I in the range of n minus 3. N value is what? 6. Sir, 6 minus 3 means what? 6 minus 3 means what? 3 times. 0, 1, 2. When I is equal to 0, D is equal to A plus B plus C. 0 plus 1 plus 2, 3. Append this. Then A is equal to B. B is equal to C. C is equal to D. Sir, next I is equal to 1. Your D value we are calculating. 1 plus 2, 3 plus 3, 6. Try to append that. Then next time 2. So D is equal, sorry, A is equal to B. B is equal to C. C is equal to D. So next D value is equal to 9, 10, 11. Try to append that. So that's all right. This is nothing but the list what we are going to get. Let us execute. I think already we executed. Right? Sir, I think you people got clear clarity about this Fibonacci sequence also. Clear, friends? Any doubts up to this?
No, sir.
Is it clear for you people?
Yes, sir.
Can we solve this in generator function?
Sir, we are getting resound from your side, sir. Whatever you are speaking, it is a little bit slow. I request you to please speak
Audible?
louder. Yeah, you are audible, but your voice is low.
Right. Now it is clear.
Yeah, tell me, sir.
So I was asking that can we solve this function into generator function also?
We can solve this by using generator functions, sir.
Yeah.
Yeah, we can do that. No problem. We can do that. Sir, clear up to this, everyone?
Yes, sir.
Right. Good. Right. So this is nothing but what we have in today's session. Sir, with this, how many chapters we completed? Actually, tentative syllabus I have given here. Okay. But sometimes I'm going with a bit neat chapters one by one, because first time, this is the first batch, right? That's why I'm going with in detail. So chapter by chapter, I may add some new concepts. Okay. Or I may change the flow of control also. Yeah, we can do like that also. No problem. If it is working, then fine. So what is the first chapter that we covered, sir? I think 1 second. Yeah. So the first chapter, what we discussed here is algorithms and analysis of algorithms, right? Algorithms and analysis of algorithms we covered. In that, in detail, we discussed about algorithm, properties of algorithm. Better I will write step by step. Right. Sir, we have seen algorithms. So in that, what is mean by algorithm, properties of algorithm, and the complexity of algorithm. Next and after that, asymptotic notations, how to represent. Okay. So big O notation. So omega notation. So theta notation. Next and after that, complexity analysis of algorithms. Then we have seen growth of functions in that constant time, linear time. Okay. Logarithmic time. Okay. Logarithmic time. 1 second, let me add that also. So in that, we have seen constant time, linear time, how it is going to work. Next and after that, logarithmic time. Next and after that, a big O of log n. Next, quadratic time, exponential time, so factorial time. Okay. So exercises also we have seen how you can calculate complexity for loops, how you can calculate complexity for nested loops part 1, how you can calculate complexity for nested loops part 2, and how to calculate for arithmetic sequence, how to calculate for double the iteration variable, how to calculate for half the iteration variable, how to calculate for consecutive statements. Okay. Next and after that, how to calculate for yeah, I think log n, how to calculate for log n. Next and after that, next example is also related to log n only, I think so. How to calculate for log n, example number 2. So next and after that, multiple loops in big O of n times. And that is the first chapter. In the second chapter, we discussed about introduction, approaches to solve the problems. So what are the constraints that we have? What are the constraints that we have? How to get idea generation. So next and after that, complexity analysis, coding part, testing part, these things we covered. And in the sample algorithms, even or odd application, we discussed. Next and after that, how to calculate maximum of 2 numbers, how to calculate minimum minimum of 2 numbers. Next and after that, how to calculate maximum, I think so, 3 numbers. How to calculate a minimum of 3 numbers. So next and after that, we have seen how to calculate maximum of 4 numbers, how to calculate minimum of 4 numbers. Next and after that, the maximum of 5 numbers, I think so. Next and after that, minimum of 5 numbers we calculated. So 1 second.
You have removed the ninth one, minimum of 5 numbers.
Major variables. So next and after that, we discussed about, we discussed the factorial of that, after that reversing a number. Next and after that, we discussed x to the power y and the sum of even digits. Also after that, Armstrong number. That last we discussed about according to the syllabus, introduction, Python basics. So tomorrow we are going to start Python inbuilt data structures are there, right? With this, I think it is completely related to the Python fundamentals. So I'm going to repeat for these 2 days. That is Thursday, Friday. You are going to get a complete fundamentals. I will cover at a top level. Okay, and already sample algorithms, all these things we have completed. Then we will see array data structure. Array means we are calling this one as a list data structure. How to work with that we will discuss in detail. Okay, so this is nothing but what is our next week plan, sir. Okay, right.
Sir, as I asked you before, when will be the hiring will get started?
Sir, we can't give guarantee for that, sir, but definitely it will be started within a few months.
Okay. Because as you earlier said that it might get started on by end of the May or June.
Yeah. Most probably it will be started, sir. I will inform you. Yeah, I have shared running notes. Sir.
Which thing are going to start, sir?
Which chapter? Data structures, sir. Data structures we are going to discuss.
No. I mean, you told us that at the end of the month, maybe.
Sir, he is asking for this recession period.
Okay.
And when will be the recruitment will be starts? That's what he is asking.
Sir, I was asking you about program about this painting positive index value character. So I was trying
That remind me tomorrow, sir, because in the data structures, in string data structure, we will talk about that. Okay.
Sir, I have a doubt. Like, yesterday we did a program on some of the prime number, and in which we you converted integer into string. So we will discuss further in like string part this type of questions.
Yeah, definitely. You are asking about recursion?
No, sir, I'm asking about the sum of the prime number. Sir, in this, sir, you gave us like 2 types of the version. In first, we just take the number and like get the modulus. After that,
we will discuss, sir. We will discuss.
Okay, thank you, sir.
Yeah, I'm going to start a new Java batch. Maybe next week, May 1st week, we are going to start a new Java batch, new Python batch will be started.
It is Java DSA.
No. Java, core Java.
Timing, sir?
Okay. What will be the timing?
Sir, it will be in the morning session, sir. Timing is not yet decided, but definitely Java batch will be there in the morning, and probably we are planning for evening also, sir. Because almost
Is it fast track batch or normal one?
Fast track batch only, sir. Because we are going to take the topics, some topics we are going to take very fastly, like collections, arrays, all these things. So it will be fast track. My classes will be maximum fast track only, sir. No, I'm not taking any Django classes.
So do we have the WhatsApp group created for this particular batch?
No. A WhatsApp group is already created, sir, but a few people are there in that group. Remaining people, just I have shared the details to the admin team. Once if I get approval, I will add. Okay.
Yeah. Sir, what are the requirements for the Spring Boot actually, sir? Prerequisite for Spring Boot.
Sir, for that Java basics is sufficient, and some knowledge on advanced Java is also required. But I'm not taking any advanced Java related classes, sir.
Sir, advanced Java, what are the topics will be going to be? Servlet, JSP, all these things?
Yeah, sir. Basics.
Servlet, JSP also required.
Yeah, servlets, JSPs, JDBC, all these things are basics, sir. But in that we have so many frameworks are there. So after completion of these basics,
Oops.
Yeah, Oops will comes under normal Java classes. Okay, right. Regarding the new batches, all these things we will talk later. Okay, sir, I'm going to close the session now. We will meet for the continuation tomorrow. So tomorrow we will have our regular classes. There we will discuss remaining things. Okay. So thank you. Good night.
Thank you, sir.